and I'll start with the presentation. And it's not death by PowerPoint by any means, don't worry. So let's move this over here. And Zoom does this really helpful thing where the chat disappears when you full screen a presentation, but I'll carry on regardless. And if you need anything, you can shout out in the chat, and Federico and David can get hold of me through something else.
Yes, sir. Right. We're right here waiting. No problem. We've got the chat open and watching. I'll stop you if there's anything happens. You do your job, Tim. We'll do ours.
Thank you, David. So yeah, just a few quick slides to basically talk about what it is we're going to be doing tonight. I think I put in the invitation, you don't necessarily have to be adept with deployments on Kubernetes or even have used Kubernetes much at all. You'll still be able to get something from the hands-on lab tonight. So just to take you through a few of the theoretical things we're going to be going through tonight. First of all, I'll introduce myself properly. I'm Tim Berry. I'm a principal training architect at A Cloud Guru, hence the shirt. We're an online on-demand training company for all the major cloud vendors. And I'm Tim H. Berry on Twitter and LinkedIn. And tonight, as I said, our workshop is managing deployments with Kubernetes. So before we get started, let's talk about what we mean by deployments. So this is quite a famous sort of diagram about the DevOps cycle of software development or software deployment. So it's kind of an infinite loop. You plan something, you code it, you build it, you test it, you create a release, and that leads to a deployment. And sometimes you've got more than one of these stages kind of happening at the same time, maybe as part of some sort of pipeline. But this is the part that we're going to think about tonight, the actual deployment part. And really, it just means, all deployment means is just how we get our software into production once it's built. And there's lots of different established patterns for doing this. And the reason we have deployment patterns is they're basically just ways of deploying things in a safe, repeatable way, because the more we can deploy safely, and then the more we can deploy, we can iterate more frequently on features and improve our software. So we're going to be looking at 3 very well-known deployment patterns tonight. And these are rolling updates. So this is more sort of common approach where you basically just bulldoze what's in place and roll an update over the top of it. You're replacing old with new. Literally, your new version replaces the old version, and it's as straightforward as that. Rolling updates are actually the default in Kubernetes as well. We're also going to be looking at Canary Testing. So if you're not familiar, this gets its name from when miners used to have a canary in a cage to detect whether there was gas in a new part of a mine. It's a lovely image to sum it up. But basically, a canary pattern of deployment is just all about testing a very small amount of production traffic with your new deployment. You obviously want to run tests as much as you can before the point of deployment to production, but sometimes you just need production traffic to test on, and that's what a canary is for. And if a canary is successful, you'll then usually roll out that deployment to the rest of your traffic. And the other pattern we're going to look at is blue-green. And blue-green is basically where you maintain 2 separate deployments and you manage them in isolation from each other, but you basically route traffic to one or the other. So you'll develop something in your blue environment, route traffic to it, and then you are free to develop the next iteration of your software in the green environment. And then once it's ready, switch the traffic over to it. If anything's wrong, you can switch back. So the other benefit of the blue-green pattern is you always basically have the last good deployed version of your software ready to go. Now, obviously, with 2 of these, you have to do some sort of traffic splitting or routing or load balancing. But these are the 3 deployment patterns that we're going to look at tonight. And we're going to, in the hands-on lab, we're actually going to do these patterns with Kubernetes deployments. Before we get into how we do that in Kubernetes, let's just go right back to the beginning, just in case it's brand new to anyone, and look at the basic building blocks we're going to need. So the first thing we're going to use is a pod. So if you're not familiar, a pod is the smallest deployable unit you can run in Kubernetes. And as you can see in my lovely diagram here, a pod holds a container. It contains a container, if you like. And the reason we don't just deploy a container on its own is because a pod gives us some really nice application-centric logic to help us deploy a container. Because a pod can hold more than one container. It can hold, well, as many as you want. It's most common that it will either contain one or two, but anything inside the pod will share an IP address, and it will share any storage that's attached to that pod. You can kind of think of a pod as a sort of mini virtual machine, although no one likes thinking of it like that. But it is useful for certain patterns. One example would be the Sidecar Pattern, where, for example, you may have an application here that needs to talk to a database, and you can have a proxy to that database in this sidecar running in the same pod. And the benefit of that is, as far as these two containers are concerned, they both exist on the same server. They can both talk to each other on localhost. They both have visibility of any attached storage. So that's our basic building block, is a pod. But we don't actually deploy pods on their own that often in Kubernetes either. We tend to use something else called the deployment object. So if we look at an example deployment for Nginx, say I want to deploy Nginx pods to serve my website. And I don't just want to deploy one pod because I'm hoping that my website's going to be reasonably popular. So I'm going to deploy 3 pods. So I define this in a deployment object. And it gives me lots of other helpful logic to help my deployments be more reliable, which we'll get to in a moment. But the first thing the deployment does when I say I need 3 pods is it gives me something called a replica set. And that's because these 3 pods are replicas of each other. They're replica pods. And so we get this replica set object inside our deployment object. And again, if you're brand new to this, you're probably thinking, why all these abstractions already? But it does make sense, and it does help you with some logic. And it brings us to our first deployment pattern, which is the rolling update. So say I've got my Nginx deployment here, and say I've said I want 3 replicas. I want them to run Nginx 1.18. And so there's my deployment object, and there's my replica set inside my deployment object. Now, say I want to effect a change. I want to change the container image to Nginx 1.19. When I change the configuration of the deployment manager knows that it has to create new pods, because these pods are running the wrong version. And the way it does this is it creates a brand new replica set, and it starts spinning up new pods. And as the new pods come up with my new updated configuration, it will terminate old pods. And it will keep doing this. It will basically do this rolling update until all of the new pods are up and running, and all of the old pods have been deleted. And there's lots of safeguards in place to make sure that a minimum percentage of pods are always available and ready. That if a certain number of pods don't come up in my new updated configuration, then the rollout can stop. And because replica sets and changes to deployments they're just configuration objects, it's very easy to roll back. I can basically just undo this change and immediately get the previous replica set spun back up if I need to. So that's the default method of updating deployments in Kubernetes. That's the rolling update. So let's look next at the Canary deployment pattern. So as you can see in this version, we've got 2 deployments. We've got our primary deployment here, and we've got our Canary deployment here. The Canary deployment is always much smaller because we're just trying to test on a small percentage of our production traffic. In this diagram, there are 3 pods in the main deployment and 1 in the Canary. In real life, this would probably be a much smaller percentage. This might be 1 pod and 10 pods, or even more. You normally go for sort of something like 5% to 10% traffic for a Canary. And the way that we test traffic against our Canary deployment is we have to have something else in front of our deployments. We have to have this piece of load balancing here. Now in Kubernetes, you have a service object, and the only thing a service object needs to do is direct traffic to pods. And you'll see this in the lab, that it does this with labels. But with that, we won't get too into the details of that here because it's much easier to understand when you do it yourself. But basically, the labeling here is just saying, I'm looking for a certain app. Maybe the app is Nginx, and I can find a pod here and a pod here and a pod here and a pod here that will serve that. So this service object will basically load balance traffic between all of these pods, regardless of which deployment they're in, which means we're going to get traffic to our Canary deployment as well to test our new version. Really easy to do in Kubernetes, which you'll see in a minute. And then the third approach, the third deployment pattern we talked about is the blue-green deployment pattern. So again, we have two different deployments. Now, the difference with blue-green is that you basically have them the same size. You have double the costs of a single production environment because you're maintaining two identical environments, or identical in terms of the resources that they're using. But this is a really safe way to manage deployments, because essentially you work on each deployment in isolation. So say I've got traffic pointing to deployment A. This is my blue deployment, and I've got version 1 of my app here. So I'm running my own app now. Forget about Nginx. I've got version 1 of my app here. Now, say my development team has a new version of my app, and they want to deploy it to production. We want to do this in a safer way possible. So we deploy it to the green deployment, deployment B over here. And we can do this completely in isolation. There's no production traffic going towards this deployment. So we can take our time, we set it all up, we make sure everything's good. And then when we're absolutely convinced it's all good to go, we make a single configuration change in our service, and we point traffic at the green deployment. Same thing again, when we're ready, a few months down the line, we're ready for version 3 of our application, we deploy it to the blue deployment again. And again, it's in isolation. We can take our time, we can run all our tests. And then when we're absolutely sure it's ready to go to version 3, we change the service object again, and we point our production traffic at version 3 in the blue deployment. But, oh no, there's a problem. We've introduced some bug in our new version. We need to switch back as quickly as possible to our last known good deployment. Now, if you were doing a rolling update, you could roll back the configuration, and those pods would spin down and spin up, and you would get back to your last good state. With a blue-green deployment, it's even quicker because, again, you just make the single configuration change, and your service object will just point your users right back at the last known good deployment. So even though a rolling update can be rolled back quite quickly, when you're dealing with much larger deployments and more complex deployments, blue-green is even safer and much more safer way to do it. You may have also heard blue-green referred to as AB or red-black. They're all pretty much the same thing. So those are the three main deployment patterns. Now, all of them rely on the deployments that you're deploying being stateless. The pods need to be able to come and go. All these deployment patterns they cannot store state anywhere. You mustn't store state in a container. The state should live somewhere else. Cloud storage, a database, any one of the many managed databases available. Because also, if your pods are stateless, it's very easy to scale them horizontally as well to react to demand. And that sums up the theory section, which hopefully gives you a bit of a primer for what we're going to be doing in the hands-on lab. So if I stop sharing my screen for just a second, and I'm going to get ready to start the lab for everyone. Now, can everyone let me know in the chat, have you all signed up for Quick Labs, or you're able to log into Quick Labs? That's the first requirement. Or I should say, maybe if anyone hasn't, or if anyone's having problems doing that, now's the time to let us know in the chat. I think everyone's good to go. Okay. So what I'm going to do in a moment is share my screen again. Yeah, I'm going to give you the link to the actual lab in just a second. I'm going to share this screen again. And I do wish the chat wouldn't disappear immediately. This is the lab we're going to be doing. I'm going to give you the, here we go. I'm going to give you the link in just a sec. So what I'm going to do is I'm going to give you this link to this spreadsheet in the chat. And what I want everyone to do is look for their name. And basically, when you find your name, first thing you're going to do is tick it. So I'll give you an example. Here's my name right at the bottom. I'm going to tick this name, which means this voucher code is being used. No one touch it. And then I'm going to use that voucher code in a minute to log into the lab. So all I want you to do right now is I'm going to give you the URL to this sheet, and please tick the box if you're using that voucher code, because we can reuse the voucher codes for the people that haven't turned up, basically. But don't log into the lab yet. There is the link to the lab there. Don't log into it just yet. Don't start it just yet, because it is on a timer and we want to all try and start roughly at the same time. So I'm going to give you the link for this here, and then I believe you should all be able to jump in and copy your code. I'll just give everyone a couple of minutes to do that.
Hey, Tim.
Yep.
While everybody's grabbing their codes there and getting set up, you've designed a couple of courses around Kubernetes and Google Cloud. What was the last course you designed?
So the most recent one I've done specifically on Kubernetes would be the GKE Basics course, which is available in the free tier at A Cloud Guru. This wasn't a rehearsed plug, honestly, but yeah, that one is in the free tier, so anyone can just sign up without paying any money, and that's a really basic primer intro to using GKE, talking about basic Kubernetes objects and deployments. And if you want to dive even deeper into GKE, my other ACG course is GKE Beginner to Pro, but you will need a subscription for that one. But the GKE Basics one I think is great for people who are new to Kubernetes, because it lets you learn about Kubernetes by deploying to it before you learn how to build it, which I think is the thing that puts a lot of people off. Okay, has anyone not got a voucher code? Pierre, you're welcome to use the voucher. We've got plenty more. So you can do the lab again, even though you've done it before. That's fine. But if anyone doesn't have a code, or if your name is not down here, let me know now. If not, we'll move on. So I'm going to grab my code here. Now, what you want to do is click on that link at the top of the sheet to load this page, and hopefully you'll be logged in. And don't click start yet, but I'm going to show you, I'll give you a tip how to do this. When you click start the lab and you tell Google you're not a robot, you enter the code here, which really helpfully, this is a 16-digit code, and these are four 4-digit boxes. Thanks, Google. So you have to enter it piece by piece, and I'll try and do it without making any mistakes, as I did earlier today. And then you click launch with access code. And then my next piece of advice is don't click open Google console, because it'll get really confused if you already have any cookies in your browser that use the Cloud Console. Open an incognito window and just go to console.cloud.google.com, and then log in with the details in the lab instruction there. So if everyone wants to start their lab now and use your voucher code, and then open an incognito window, I'll give you that link, console.cloud.google.com, and then put the credentials in there, and then we'll get started. I'm going to swap these around. Once you've put your username and password in, you just accept the terms. You'll get prompted about protecting your account. Obviously, you don't need a recovery phone number or recovery email. This is a temporary account, so just click confirm. and agree to the terms and conditions. Don't tick the email updates thing because, again, it's not a real account. And we should be all in, ready to go. Give everyone a couple of minutes. If anyone's having any problems logging in or getting the voucher to work, let us know in the chat now. Looks like everyone's all good. So there's some information at the beginning of the lab description, which is basically what I've been talking about already. DevOps practices makes use of multiple deployments such as continuous deployment, blue, green, and canary. There's a big wall of text here about heterogeneous deployments in multi-cloud and hybrid cloud situations. You can ignore all that. It's not really relevant to this lab. But once you've got the lab up and running, the first thing we're going to do is activate the Cloud Shell. So this is under the setup section. Chris, feel free to grab another token from someone that hasn't used it. Just tick it that you're using it if the one that you tried to use isn't working. Cool. Okay. So once you're in, basically, you've got the GCP dashboard here. We're going to activate the Cloud Shell. Actually, before we do that, one thing, this is another thing that Gcloud does, but you'll notice at the top here, it says select a project. So you want to do this before you do anything else. Otherwise, you'll end up having to set your project manually. Just find the project named Gcloud GCP and some part of a UUID here. Make sure you have that project selected. And then we're going to activate the Cloud Shell by clicking Activate Cloud Shell. If you've not used this before, Cloud Shell's amazing. It's been around for years, and they just keep adding more features to it. But it's basically a little developer VM, terminal, editor, everything you need built right into the console. So we'll just give that a few seconds to power up. I'll try and make the text a bit bigger as well. In fact, I think this whole lab takes place in the shell, so I might just do this in a new window and make it even bigger. And hopefully you can all read it a bit better. Once you've got the Cloud Shell up and running, good thing to do is just type Gcloud config list, just to make sure that it's set up and configured for what you want to do. And what you're looking for here is you've got the project selected. You'll also know that's the case if you've got the project in yellow as part of your prompt. And that's pretty much it for getting set up with the Cloud Terminal. The next thing we need to do is set a default compute zone. The default compute zone is basically...
one sec there, Tim.
Yep.
The project is the GCP project ID on the left-hand side where you get your username and password for. Just when you're selecting that from the drop-down, that's the project you're looking for, Gcloud, GCP, and whatever the code is at the end there.
Yeah, it'll be the only one with a unique ID in it.
No problem.
Cool. So once you've got the Cloud Shell set up, you've got your project set. If you do need to set your project, I should say it's Gcloud config set project, and then the name of your project. And then once that's done, we're going to set some more configuration. We're basically just going to set the default compute zone. So Shakti's saying no resources to display. You are checking the project there. I'm gonna let David take that in chat just so I carry on because mine is on a timer. But we're going to set the default compute zone there. And the instructions tell us to set it to US Central 1A, so we'll just do that. The next thing we're going to do is we're going to get the sample code for the lab. Surprisingly, it's not in a Git repo, it's actually in a public cloud storage bucket. So we're going to use gsutil to just copy the contents of that cloud storage bucket into a directory in our project. With Gcloud, you can just you can just click this copy to clipboard button rather than try and type out that whole thing and get the bucket name wrong, and then just paste it into your Cloud shell. And then we just change into that directory, which means my prompt now takes up my the entire width of my terminal. And once you've got all the files that we need there, the next thing to do is to create the cluster. So we're going to need to run this command here, gcloud container clusters create. Bootcamp is the name of the cluster that we're going to give it. --num minus nodes 5. We're going to have 5 nodes. --minus scopes, and this just gives basic permission scopes to the nodes in our cluster. So if you're not familiar with GKE, the control plane and all the management stuff for Kubernetes is kind of done for you behind the scenes. But the nodes where your workloads actually run are just compute engine instances. So you'll be able to see those in your project. So we're just going to copy this command here and run that in the terminal. You'll see some warnings. These are just generally heads up about things that are going to change. So it's nothing to worry about. And then it will take a couple of minutes to spin up the cluster. So while that's happening, let me just check. Yeah. Shakti, I would try that again in an incognito window. It gets confused with other Google logins and cookies and things like that. But yeah, try it in an incognito window and you should be good. So at this point, hopefully everyone is spinning up a GKE cluster. So if you've got any problems at the moment, let us know in the chat.
Well, that's going there, Tim. What courses do you recommend to pass? Let's say the ACE, which would be the hands-on Google certification exam that we do in the developers groups. We try to support people getting certification. What courses would you recommend to go for that?
So, I mean, this is starting to sound like a paid-for promotion for a Cloud Guru. We obviously have a Cert prep course for the Associate Cloud Engineer Cert. So that's taught by a friend of mine called Matthias. That'll take you through everything you need to know to pass the Associate Cloud Engineer Cert. In true British fashion, I should say, there are alternative training is available. There are courses available on Coursera that are produced by Google themselves, and there are quests available in Quick Labs that you can go through as well. I mean, my advice, if you want to get the Associate Cloud Engineer certificate, is to read the public exam guide and just kind of make a list of all the things it mentions that have a documentation page on cloud.google.com and read the docs. It's kind of one of those things that goes without saying, read the manual, but that they're actually pretty easy to digest. I think the Google Cloud documentation pages, and you get a lot of stuff from just reading from start to finish in them, and then get hands-on and actually build stuff. I think the Google certifications really are a test of your experience more than your knowledge. What you've actually done rather than what you've learned. But yeah, obviously, if you join ACG, it's all there as well.
Completely agree. But the reason I brought it up was I passed the ACE last year, and while there is a lot from Google themselves around the documentation, I don't learn well that way. So when I wanted to cram, I signed up and got the week free, the free trial from a Cloud Guru, and found it great. That's most of the reason I flew through the exam. So that's why I was bringing it up. And it doesn't hurt that you now work there, but we didn't know each other at the time. So,
so pretty soon everyone should now be getting this sort of readout in their terminal that their cluster is up and running. You can actually pop back into the console if you want and have a look under the Kubernetes Engine section. I'll just hide all this stuff that comes up, and there's my cluster. There's some information about it there. About the nodes, but as I say, we're going to be doing everything in the shell. Now, if you've ever used Kubernetes before as well, you know that the command line tool that we use is kubectl. You may pronounce that differently. That's entirely your prerogative. And you need to configure a context in kubectl for authentication. The nice thing about setting up a GKE cluster on the command line is that that's just done for you. That's the last thing it does here. It says kubeconfig entry generated. So I'm already able to communicate with my cluster using kubectl. I'm just going to clear my screen. Yeah, so I can, for example, type, kubectl get nodes. And there's all my nodes. So we've got our code, and I should be able to see the code there. And we've got our cluster set up. So the first thing the lab wants us to do is learn about the deployment object. So kubectl has this great thing where, obviously, as we've already said, everything in Kubernetes is an object. And you can pick any object you want to know about and use kubectl explain. So I'll use kubectl explain deployment. And it'll tell me, kind of like a man page, this is what a deployment is. And these are the fields it expects to have in its configuration for a deployment: API version, kind, metadata, etc. Now, obviously, as you probably guessed, there's a lot more configuration under each of those things. So the other thing you can do is add ---- recursive. And it'll show you absolutely everything you can put in a deployment object, which may seem overwhelming, but you don't need to worry about most of it. It's just lots and lots and lots of options for declaring anything you might want to create in a deployment. And you can pick any one of these values and, again, use kubectl explain to tell you something about one of these values. So I know, for example, there's one called metadata.name. And that field, it'll say there, it's the name that must be unique within the namespace that we give to the deployment. So what we're going to do now is actually create the first deployment. The YAML that we're going to use has already been written for us. We don't need to write any from scratch, which is great. But we are going to make one small change to this YAML file before we deploy it. In the instructions here, it wants us to use Vi or Vim. I'm going to actually use the Cloud Shell editor because I'm screen sharing, and it'll help show it more easily to people what I'm doing. So if I go into here, we're going to look in the deployments directory, and these are the YAML manifests that basically configure all our deployment objects. And we're going to look at this one called auth.yaml. So we're going to create a deployment called auth, which is obviously going to be the authentication layer of our demo application. There's going to be one replica, so it's only going to spin up one pod. And the specification for that pod, which we can find in the spec section, is that it has a single container. That container uses this image called auth from the amazing Kelsey Hightower. And it has some other configuration in here. We open a couple of ports, 80 and 81. We define some resource limits. I won't get too into the weeds here, but if you configure limits for a container and a process in that container attempts to exceed those limits, Kubernetes will kill it. So we've got some limits on here, and we've also got some probes, liveness and readiness probes. Bit outside the scope of this lab, but liveness and readiness probes help to do things like make sure your pods are healthy and tell the deployment manager when they're ready, which is useful when you're doing rolling updates. But the first thing we're going to do with this deployment before we deploy it is we're going to change this. We don't want to run version 2 of the auth container. So we just change that to 1. That's on line 18 if you're in Vi. As you can see, I'm just doing it in the Cloud Shell editor. And once we've updated that, we can now create the deployment. Now, I'm going to advise against using kubectl create. You can create deployments with kubectl create, but it's kind of an imperative command. All the kubectl commands, when you're dealing with manifests, are basically just passing this information to the API so that the control plane can do something with that information. When you use kubectl create, it's an imperative command. It's kind of like a one-off thing. What we were going to use instead, as my advice, is kubectl apply. That creates a declarative configuration that then we can change. And you'll see why that we want to do that in a minute. So even though it says kubectl create in the instructions, we're going to use kubectl apply. So let's go back to the terminal. Just clear it here, and just make sure that I have updated that file. I can see, yep, we're at version 1. So all I'm going to do is type kubectl apply -f to specify that it's a file, obviously. Deployments auth.yaml. And it comes back and says it's created it. That doesn't necessarily mean it's ready or the pods have spun up or anything, but it's created the deployment object for us. We can confirm that with kubectl get deployments. And there it is. We can see inside of the deployment that there is a replica set with kubectl get replica sets. So that's the configuration object that holds our identical pods. And we can also list the pods themselves with kubectl get pods. Of course, there's only one at the moment, but we can see that's up and running, has been for 35 seconds. So now we've got our auth deployment. We want to allow network traffic to reach that deployment in our stack. So we're going to create the service next. We'll have a quick look. It doesn't tell us to do this in the lab, but we'll have a quick look at the service manifest as well, just so you can see how simple it is. And all the service manifest is doing is creating a service called auth and saying, we're going to hit this on port 80 in the port section here. And using the selector, this is how the service is going to direct traffic to those pods. So the selector basically just has one key value pair here, which is just app equals auth. And if we compare that to the deployment file, we can see that we've got labels here, app equals auth and track equals stable. This is just arbitrary metadata labeling. We can put anything we want in here. But by having this in the service manifest, it means that traffic for this service is going to hit these pods. So, wrong window. OK. So again, I'm going to use kubectl apply -f services auth.yaml. And now I have a service for my auth deployment. I can have a look at it with kubectl get services. And I can see it's there. It has its own cluster IP. So it's accessible internally within my cluster for other applications to reach. The next thing we're going to create is the hello deployment. We don't need to look at the manifest for these. If you've ever seen Kelsey Hightower's GitHub repo for this stuff, it's basically just a kind of 3-tier app where you have the auth service, a front end, and the back end application, which is the actual Hello World application itself. So these YAML files are going to look very similar to the ones we've just seen, just a different container. So we'll just do kubectl apply -f deployments hello.yaml to create the hello deployment, and kubectl apply -f services hello.yaml to create the service. So that's 2 parts of our stack. Now, for the front end, we need to do a couple bits of extra work. The first thing we're going to do is create a secret. Now, Kubernetes has a couple of different ways of storing configuration and configuration values, because obviously if you're deploying things that are stateless, you want to be using reusable, immutable container images. But sometimes, your configuration might change. It might change from environment to environment or deployment to deployment. So there's a couple of different ways to inject configuration into a running container. One of those is with something called a config map, which is just a way of storing a configuration file that can then be referred to in a deployment. And if you have configuration that's sensitive, you can use a secret, which is just basically an opaque way of storing configuration. And you can also encrypt secrets, although we're not going to do that here. So we'll create the secret first. And we just do that with kubectl create. Now we are going to use create because this is imperative. It's a one-off thing. So we do kubectl create secret. That's the type of the object we're creating. Generic, because it's just a generic secret. There are different types of secrets, but this one's generic. And we're going to call it TLS certs. we say --from -file, and we specify the directory in these files that we've downloaded that we're going to use to create that secret. That creates the secret object. And I'll show you in a second how we refer to that in our deployment. But before we do that, we're going to create another object. This time we're going to do kubectl create, and we're going to create a config map. The config map is called Nginx -frontend -conf. And again, we're doing from file, and the file is nginx frontend.conf. And a config map, like I said, is just a way of storing either an actual map of configuration values or a configuration file itself. So now we've created that. Now we can roll out our front-end deployment and service. And that's the next step. Before we do that, I'll just show you. The front-end service, again, it's very straightforward. It's listening on port 443, and it's just has a selector to find pods with the label app equals front-end. But if we look at the front-end deployment, you'll see we have a couple of extra bits of configuration in here. We're deploying Nginx, but we're using some volume mounts. And a volume mount is just a way of injecting some storage into a container once it's up and running. And you can see here we've got our Nginx front-end and our TLS certs. And those mounts have to use volumes that we specify, which we've done at the bottom here. So we have a volume called TLS certs, which is created from the secret that we just created, and a volume called Nginx frontend conf, which is created with the config map that we just created. And if you remember right back to the beginning when we looked at that diagram of a pod, you could have multiple containers in the same pod, which can use the same volumes, which is very useful. So let's now kubectl apply -f deployments hello.yaml to create the deployment. kubectl apply -f services. Oh, my mistake. We've already okay. So I've just reapplied the hello deployment, but we've already deployed it. But again, I did it as a declarative deployment, so it hasn't changed anything because the hello deployment hasn't changed. So that mistake didn't cause any harm, which is good. What I meant to do was kubectl apply -f deployments front end. That's the one we were looking at. And kubectl apply -f services frontend.yaml. So we should now have 3 deployments, which we do, and 3 services, which we do. Now our front-end service is of type load balancer, so that's actually going to give us an external IP address, but it takes a few minutes for the cloud load balancer to assign that. So we'll just give it a minute or so. Hopefully everyone's at the same point on the lab as I am. Oh, and there we go. So I've got my external IP address. Now it's using its own SSL certificate, so we won't hit that in a browser. We can use curl with that external IP. If you copy this instruction here, though, from the lab, what this is doing basically is running kubectl get service front end and extracting from the JSON path the actual ingress IP address, and then running that against curl. So it'll do that all in one line for you. And you get the message, hello. And you've traversed the front end, the auth layer, and got to the back end to get that message. So that's our first deployment, our first couple of deployments. Although we haven't redeployed anything yet, which is obviously the point of this lab. You can check this button, click the check my progress button in the lab to make sure everything's working for you. So real quick, before we actually get into how we redeploy this deployment, we're going to scale it, as I mentioned in the slides as well. Having these things as stateless pods means it's really easy to scale them. And if you remember, if we look at our pods right now, we've got 3 pods running in the hello deployment. We can easily scale that up with kubectl scale deployment hello as the name of the deployment, and then ---- replicas, and scale it up to 5. And now we can see we've got 5 pods. A couple of them aren't ready yet, but give them a second and they will be. Oh, they will be in a minute anyway. You can also, it doesn't go into it in this lab, but you can also very easily set up an autoscaler for that. It's called a horizontal pod autoscaler. And you need to have the metrics server running in Kubernetes, which I'm pretty sure is default in GKE now. And you can easily set it to say things like, if my pods are over 60% average CPU, spin up new pods, and it will horizontally scale up and down in your deployments. It's great stuff. Let's scale that back down to 3 pods by running the same command again and just changing that number of replicas to 3. And then you can see that we're nearly back down to 3 already. There's 1 still terminating there. So now we're on to our first deployment pattern, which is the rolling update. And again, as we discussed in the slides, this is just basically going to create a new replica set to affect the new configuration we want, and then replace old pods with new pods. So let's just check. Yeah, we're back down to 3 pods. I'm going to clear my screen. Now, I could edit this file quite easily, the hello deployment file, and then do kubectl apply -f again. The lab instructions actually want to show us a different way of doing it, which is kind of a live edit. I'm not sure you'd ever do this in a production system, but if you do kubectl edit deployment and then the name of the deployment, it will actually load the live state of that deployment into your text editor. And then if I find the containers we're running, here we go. So here's the container image, and I can basically just edit this live, change this to, and this is on line 40 because we have all the extra state in there. But basically, I've changed the image tag from 1.0.0 to 2.0.0. And if I save this file and quit, which if you're not familiar with Vim is just escape, :WQ, return. That's edited that configuration live. And we should be now seeing changes. So if I show you a kubectl get replica sets, you can see we now have 2 replica sets for our hello deployment because we've got the old one and the new one, and the new one is spinning up. You'll notice as well in the new one, it's at 1 pod because that is, no, that's not correct. Why is the new one at 1 pod? Maybe because it hasn't finished spinning up yet. But it's going to terminate the old replica set and spin up the new one. And we can confirm the status of that rollout with kubectl rollout history deployment /hello. So that's showing us that we've had 2 revisions in the history. And we can look at the status of it with kubectl rollout status. And we can see it successfully rolled out. And you can see the other instructions in the lab as well. You can pause a deployment halfway through, but this one's already completed. So let's see how many pods have we got now in the hello. Yeah, we're back up to 3. Okay. I think I just got confused reading that readout before. So we've essentially done a rolling update now. We've made a configuration change. It's created a new replica set to affect that new change, a new version of the container that's running, and we've now got 3 pods. If you do pause a rolling update, you can resume it with kubectl rollout resume, and obviously we've already seen kubectl rollout status. So as we said, the nice thing with rolling updates is it's very easy to roll back. If you just want to go back to the last one you had, you simply do kubectl rollout undo deployment and the name of the deployment. That'll just roll back the change we just made. you can watch that happen if you do kubectl get pods -w to watch. And slowly but surely, we should see some pods being terminated and other pods being created until we're back to our previous configuration state, which I believe was at version 1. Yeah. That's right, isn't it? Because we changed it to version 2. Yeah. So rolling updates, it takes time to roll from one to the other. And when you're rolling out a new version of something, that's good because you don't want it to be too quick. You want it to make sure that it's doing it successfully. And that's why you have things built into there, such as thresholds for how many pods it will accept being in a not ready state and how many pods it will accept being over the number of replicas overall, because also you don't want it to just spin up a ton of resources and cost you more money. Rolling back, you can, if there's a problem and you want to roll back, that's fine. It can take a little bit of time to spin that replica set back up. So that's rolling updates. Let's move on to Canary deployments. So as we've seen, as we saw in this slides, Canary deployments are a way to divert a small amount of production traffic to a second deployment just to test a new version of an app. And we saw this in the YAML I showed you. The service object will match on app equals hello, but we've got a deployment here with track equals canary, and a deployment here. I think this track was called something else. It was no, it didn't even have a track label. Oh, it does, track stable. But the service selector doesn't care what track it's in. It will only match on app hello. So it's going to send traffic to all of the pods that match that. So let's have a look at our Canary deployment, which is here. So this is a different version of the app, and it adds this label here, track canary. So let's do kubectl apply -f deployments hello canary. And if we do kubectl get deployments, oops, what did I type wrong? Kubectl get deployments. We can now see that we've, in addition to our auth front end and hello deployments, we've got a hello canary. And if I do a kubectl get pods, we've got 3 of our original deployment and 1 canary pod running. So basically that means that 25% of the pods that will respond to requests are going to have a different version. And when I say 25% of the pods, it's 1 pod. We can verify that. Again, we can use this, if we just copy and paste this command from the lab instructions. This is just getting that front-end IP again, but also appending /version. So it will tell us the version that's responding. We've got version 1 that time. And just keep running this command. There we go. That's the canary. We keep running it, and I got the canary again. And this will basically load balance between the pods. Me pressing my up arrow in return is not a very scientific way of showing it to you, but if you did this enough times, you would roughly get the canary 25% of the time. And I'll click the check my progress button. There is a little section in the lab instructions here about Canary deployments in production and how you can manage session affinity. But it's basically, it says here, it's too difficult to set this up in a lab environment. So feel free to read this, but we're not actually going to be doing this part. I think we're okay for lab time, if everyone's roughly on the same time as mine.
Tim, just apologies to interrupt.
Okay.
There is a question from Shakti about the type of deployment.
Yep. Is there a recreate type? Can you please explain the type of deployment? So I think what you're referring to there is the update strategy for when you're updating a deployment, and the way that it manages those the pods being deployed in the new replica set. I think that's what you mean. I'm not really sure what else you might mean by that. perhaps the confusion is that we're talking about three different types of deployment, as in rolling update, Canary, and blue-green. But what I should say is they're types of deployment pattern. And in Kubernetes, a deployment is a deployment. The way you update it is the pattern, but everything is still a deployment object. And in the deployment object, you can specify a strategy for a type of rolling update. And under that rolling update strategy, that's where you would specify things like your max surge, how many extra pods you will tolerate, the maximum unavailable pods that you can have during an update, and that sort of thing. If you Google Kubernetes rolling update strategy, you'll get the docs page, and it's all in there. I hope that answers your question. Cool. Okay, let's move on to our final deployment pattern, which is blue-green. As we said before, this is a really safe way of managing updates to an application, especially if you've got very complex deployments, because the change to users from a traffic point of view is almost instantaneous when you update the service object. The only problem is that you are maintaining twice the resources, which, depending on the size of your deployment, can obviously be quite expensive. So we're going to use the existing hello service that we created, but we're going to update it so that it has an additional selector. So if I show you in the services right now, we're using, this is the service definition. So this is sending all traffic for the hello service to just any pod that matches app hello. We're going to replace this with a new definition, which is contained in the hello blue.yaml file. But because we're doing kubectl apply, it's just going to update the object we've already created. So it's still the hello service, but it's going to add this additional selector. That means it's only going to send traffic to pods that match both of these selectors, app equals hello and version equals 1.0.0. That effectively gives us a blue deployment where all our pods will be version 1.0.0. So we can do that by doing kubectl apply -f services hello blue.yaml. And again, that just updates the hello object in place. So now our hello service will only, as I said, route traffic to pods that match both those selectors. So now we need to create a green deployment. We've already got a deployment running a bunch of pods that are version 1.0.0. So we're going to create a green deployment, which is, you can see the YAML here in the lab instructions. It's exactly the same, except it has this label of version 2.0.0, and that's the version of the image it's going to use. So we'll do kubectl apply -f deployments hello green.yaml. And if I do kubectl get pods, well, I'll give that a minute to come up. So our original deployment, which is just hello, is running version 1, and our green deployment is running version 2. Let's see if they're up and running. And they're up and running. Now, again, we'll copy and paste this curl instruction here to basically just query the version number of the service that gets returned. And we see version 1. That's because our service, if we just remind ourselves of the YAML, it's only going to point to pods that match version 1.0.0. We're pointing to our blue deployment, basically. Now we can make the switch to the green deployment by just updating the service object again. And if we look in our pre-written YAML here, we just use this file, which again, it's updating exactly the same object. It's just changing the selector to match pods that have version equals 2.0.0. So let's do that. kubectl apply -f services hello green.yaml. And if I run the curl command again, now I'm seeing version 2 because I've immediately redirected traffic to my green deployment. As I said, it's almost instantaneous. I mean, it takes a couple of seconds for the service object to update, but the pods are already there and ready. That's the great thing of being able to develop for a blue or a green deployment in isolation of the other one. Now, again, if I want to roll back, maybe there's a problem with my green deployment. I don't want to keep production traffic going to it, so I just roll it back. And again, all I'm doing by applying these YAML files is just changing the pre-existing object. These are just two different definitions of the same object. So I'm changing it back to blue. And now if I use curl again, I'm back to version 1, pointing back to my blue deployment. And that is blue-green deployments, and that is the conclusion of our lab.